In this video, we are going to understand the concept of Huffman coding. It is a type of source coding. You know that we have two types of source coding technique, Shannon-Fano and Huffman. Shannon-Fano coding technique we have already covered in the previous video. Today we are going to understand the concept of Huffman coding. So with the help of Huffman coding also we are calculating the coding efficiency, and the formula will remain same, which is eta is equals to hx upon L bar log m. This formula we have already used in Shannon-Fano coding technique, and when we calculated the coding efficiency using Shannon-Fano, I told you that the first step is to arrange all the values in decreasing order. The step will remain same for this method also. That means in Huffman coding also you have to arrange all the probabilities in descending order or in decreasing order. This is very essential part which you need to be take care of. Now let us take an example to understand the concept of Huffman coding. Let us assume that a source is transmitting 6 messages having the probabilities 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32 and 1 by 32. These are 1, 2, 3, 4, 5 and 6 messages of different probabilities. Now how this process works, let us understand. So these messages or these probabilities are already in decreasing order, so need not to arrange these values in decreasing order. Now the next step for the Huffman coding is we have to reduce the code by adding bottommost two values. Now remember one thing, when you add bottommost two values, the sum of the bottommost two values will be arranged again in the decreasing order in the next column. This way we have to process till we get last two values. So this process I am talking about when you are taking m is equal to 2. In the exam it will be given to you that you have to solve the question using m is equal to 2 or m is equal to 3 or m is equal to 4, where m is the number of symbols. That means how many symbols you have to use for the calculation of coding efficiency. And if it is not given in the exam, then it is up to you which number you are going to take. Usually by default we take m is equal to 2. So if m is equal to 2, we add bottommost two values, and if m is equal to 3, we will add bottommost 3 values, and that process we will continue till we get 3 final probabilities. This is how this process works. So let us add these values, bottommost two values. Sum of these two is 1 by 16. So the next column would be 1 by 2, 1 by 4, 1 by 8, 1 by 16, and the sum of these two is 1 by 16. I am indicating it with the help of an arrow. That means this 1 by 16 is the sum of these two values, and this 1 by 16 is nothing but the previous value fetched from the previous column. Again this procedure will remain same. 1 by 32 and 1 by 32, remaining values we will write like this. So 1 by 16 plus 1 by 16 will become 1 by 8. Arrow is indicating this is the sum of these two values. Again same process, 1 by 2, 1 by 4 and 1 by 4, and then finally 1 by 2 and 1 by 2. So we have to perform this operation till we get two values or two probabilities or two messages. Now the next step, that means we need to assign the different codes to these values. I am using different color of marker for this to understand the concept. The thing is, now we have to give two symbols because we are using m is equal to 2. Two symbols, that means 0 and 1, to bottommost two values of all the columns. In this column there are only two values, so one message will be given the code as 0, the another message will be given the code as 1. Now the next column, bottommost two values given 0, 1. Bottommost two values 0, 1, 0, 1, 0, 1. Now we will move in the reverse direction. This 1 by 2 is having the same code 0 fetched from the column, last column, and now this 1 by 2 is the sum of these two values, and the code of this 1 by 2 is 1. This one we will put in front of this. So now we got the new code for these 1 by 4s. First 1 by 4 is having code 1 0 and second 1 by 4 is having code 1 1. Now again move. Next 1 by 2 is having code 0. So I can write 0 to all this 1 by 2. Then 1 by 4 it is having code 1 0. And these two sum is 1 by 4. The code is 1 1. This whole 1 1 I will put in front of this. So the code for both 1 by 8 is 110 and 111. So 1 4, 1 by 4, code 10, 1 by 8, code 110, and 1 by 16 and 1 by 16 added and got 1 by 8, which is having code 111. This 111 we will keep in front of this. So the new code for both 1 by 16 is this. Again moving forward, this is 10, this 1 by 8 is 110, this 1 by 16 is 111, and this 4 ones I will write in front of this. So this column now is the final code which we require. So these are the probabilities and these are the corresponding code words. So this last column I will write again to understand the concept better. You have code like this corresponding to their probability values. So 1 by 2 is having code 0, 1 by 4 is having code 10, 1 by 8 is having code 110, 1 by 16 110, then 4 1 and 0, and finally 5 ones. What is the aim of our coding? The concept should be like this: all the codes should have unique code. That means no two messages should have the same code. Here you can see all the messages are having different codes. Now I will write the code length corresponding to these values. The code length for this particular message is 1 because you are using only one symbol. Code length for this message is 2 because using two symbols. Here code length is 3, 4, 5 and 5. So this is how you can write the different messages and their corresponding codes and their corresponding code length. Now finally we will calculate the coding efficiency eta, which is hx upon L bar log m. Okay, so first we will calculate hx with the help of the formula of hx which we have discussed in the previous videos. So eta is equals to hx upon L bar log m, where hx is equals to summation pi log 1 by pi. I is equal to 1 to n. So you have 6 values. Hx would be hx is equals to 1 by 2 log 1 upon 1 by 2 plus 1 by 4 log 1 upon 1 by 4 plus 1 by 8 log 1 upon 1 by 8 plus 1 by 16 log 1 upon 1 by 16 plus 1 by 32 log 1 upon 1 by 32, and this value is coming twice, so into 2. So now hx can be written as 1 by 2 log 2, because this comes to the numerator. Then 1 by 4 log 4 plus 1 by 8 log 8 plus 1 by 16 log 16 plus 1 by 32 log 32 into 2, because it is coming twice. Finally hx is equals to, as you know, log 2 with base 2 will become what? 1, and you can write 4 as 2 square, so it will become 2 log 2. Again log 2 will become 1, so here you will get only 2. Similarly 2 cube, 2 raised to the power 4 and 2 raised to the power 5. So here you will get 3, here you will get 4, and here you will get 5, because log 2 base 2 will become 1. So your final answer will be 1 by 2 plus log 4 is 2, so 2 by 4, log 8 is 3, so 3 by 8 plus 4 by 16 plus 5 by 32 into 5 by into 2, that is 10 by 32. So by solving this you will get 62 by 32 or 31 by 16. So next step is what? You have to calculate L bar. What is L bar? L bar is Ni into Ti. That means the probability and its corresponding length. So 1 by 2 into 1 plus 1 by 4 into 2 plus 1 by 8 into 3 plus 1 by 16 into 4 plus 1 by 32 into 5, and this is twice, because both the 1 by 32 is having length 5, so you can write it into 2. So you are getting the same result, which is 62 by 32, that is 31 by 16. Now log m, where m is equal to 2, so log 2 base 2 will become 1. So your formula eta is hx upon L bar. Hx is 31 by 16, L bar is 31 by 16, so that means eta is equals to 1, or percentage eta is 100%. So the coding efficiency for this particular problem is having 100% using Huffman coding. So I hope you understand the concept of Huffman coding, how you can solve the question using Huffman code and how you can calculate the coding efficiency. Now we will solve this question. The value will remain same, only thing is we will change the value of m. So now we will solve this question with m is equal to 3. So now we can solve this question by adding one more probability. By adding one more probability with 0 value, does not make any difference in the calculation, but it will solve our problem, the problem which we are facing in even number of messages. So now what you have to do, you just need to add bottommost 3 messages. The next column would be 1 by 2, 1 by 4, 1 by 8, 1 by 16 and 1 by 16. Next column would be 1 by 2, 1 by 4 and 1 by 4. Correct? So now you got 3 messages. You just need to now give the codes, 3 different codes, 0, 1, 2, 0, 1, 2, 0, 1, 2. 3 different symbols to bottommost 3 values. Now the next column, 1 by 2 is having code 0, 1 by 2 is having code 0. This 1 by 4 is having code 1, and these 3 values will be having new code 20, 21 and 22, because the sum of these 3 values is 1 by 4 and the code for 1 by 4 is 2. So this 2 we will put in front of this previous codes. So the new code for this is 20, 21 and 22. Again move to this 1 by 4 having code 1. This 1 by 8 is having code 20. this 1 by 16 is having code 2 1, and these three values are having code 2 2 0, 2 2 1 and 2 2 2. So our final table would be something like this. This is 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32 and 1 by 32. 1 by 2 is having code 0, 1 by 4 is having code 1, 1 by 8 2 0, 1 by 16 2 1, 1 by 32 2 2 0 and 2 2 1. 0 into anything would be 0, so you will be discarding this final message because it is of no use to us. We are having only this much code which is sufficient for us. Now the code length for this would be 1 1 2 2 3 and 3. Okay, so hx will remain same, which is 31 by 16. L bar now will be changed, which is 1 by 2 into 1 plus 1 by 4 into 1 plus 1 by 8 into 2 plus 1 by 16 into 2 plus 1 by 32 into 3 into 2, because it is coming twice. So that is 1 by 2 plus 1 by 4 plus 1 by 4 plus 1 by 8 plus 6 by 32. So you can solve this value, calculate the L bar, and then final efficiency eta would be Hx upon L bar log m. Now remember one thing here, m is not 2, so log 2 base 2 would be 1, but here m is equal to 3, so this will be log 3 base 2. You cannot neglect this value, so you have to take this value also, and then you can calculate the efficiency of this particular method using m is equal to 3. Now you can calculate the values and write your answer in the comment section. I hope you understand the concept of Huffman coding, and now you can solve the question using m is equal to 2 as well as using m is equal to 3.